Happy Monday, everyone. Okay, happy Monday. Welcome to Build, and thank you for coming here. I know this is fairly late in the day, and it's been quite a busy day for everyone, I'm sure. We're here to talk about how to design always-on applications on Azure. And with me, I have in the audience here Dave Buse from Adobe, Raj Ganapati from Microsoft, and I'm Saad Latki from Microsoft as well. So we have an interesting session here. It's going to be a combination of talking a little bit about how Azure views resiliency, high availability, and the various mechanisms that you can use in your applications. And then Adobe is going to basically show you a real-life example of how they've built some applications running on Azure that deliver to these high availability promises. Now, how many of you are actually running a live service today? Just show of hands. OK. And how many of you love waking up at 3 a.m. in the morning and fixing that service? Show of hands. OK, that's roughly the ratio usually that we expect, right? Like lots of hands went up at the beginning, significantly less on the second question. And I don't really know why any hands went up on the second question, to be honest with you. But we're here to talk about that. So what we're going to do at the end of this presentation is give you a few patterns of how you build such that the application itself can stay on, despite the fact that there's natural disasters or various software bugs that I personally never have introduced into any of the code that I've written, but I'm sure others have. And so we're going to talk about how to deflect some of these and make sure that the application continues working. And what we're going to do here is we're going to start with a video, a short video, to set up the stage for how we target all of this conversation. And it's a combo between Microsoft and Adobe as well.
At Microsoft, we are committed to building the largest hyperscale infrastructure on Earth, built with a level of resiliency and high availability that allows our most sophisticated enterprise customers to use our planetary scale infrastructure to run their businesses. Availability zones allows our customers to protect themselves from a failure such as a fire, a power outage, or a network problem.
There are no reasons to be down in today's world. So continuous uptime, continuous delivery of our services without interruption are just crucial to the business that we're in. The marketing team's job is to get Adobe into the news. My job is to keep Adobe out of the news.
So in Microsoft Azure, availability zones protect you from data center level failures. And with our remote region strategy, we protect customers from serious failures that may occur inside a country. And we do this whilst protecting their data residency.
Adobe's made the choice to use availability zones because of the geographic separation that it gives us. It allows us to deliver a better SLA for our customers.
We are committed to not just providing the highest level of availability and resiliency, but helping our customers validate that their applications continue to work in the event that there is a data center failure or a natural disaster.
We recently had an opportunity to work with Microsoft in a zone down drill where they brought an entire region down one zone at a time, and we got to learn about how our system was going to respond. We also got the opportunity to run war games and train our people how to respond in those situations. It was very much a non-event. Things went very, very smoothly for the failover transition of our systems on Azure. That's not something we've been able to do with anyone else before.
At Microsoft, we are building the largest infrastructure in the world for our Azure cloud computing platform. We're investing billions of dollars so that our customers don't have to, and we're covering the globe with the most resilient and redundant infrastructure. And this platform that we are building for our customers allows the most sophisticated, highly secure, highly available customers to be utilizing our cloud to be running their businesses and transforming their businesses as they look to the future.
Okay, what do you guys think? Okay, pretty cool stuff. So let me just summarize a few key points that we're going to hit up on in this talk from the video. First of all, we're going to talk about the various resiliency mechanisms that Azure has, including availability zones, and how you can leverage them in your application. The other thing that we talked about here is any kind of high availability or disaster recovery type of plan is as good as you being able to exercise it and test that it actually works. And so we're going to talk a little bit about how you validate some of these things on Azure as well. And then third, we're going to give you a little bit more of an in-depth view of how we architect and build our infrastructure in a way that you guys can leverage it from the application perspective. Okay? All right. So with that, let's look at the portfolio of what we consider business continuity. So you have high availability, which in general means how do you make sure that your application continues running in the face of a disaster within the scope usually of a region. And typically, high availability is often thought about in terms of roughly a low latency envelope, meaning that you can generally afford to do things like synchronous replication across your app, making sure that there's various active systems running in various different locations at the same time. Now, you move out of that world into what we consider disaster recovery. And that's effectively something that might take down, let's say, a metropolitan area, a city, a very large grid or multiple grids of power. And that could be as simple as a software bug sometimes that can take down that large of a scale of a deployment. But when you have that, then you also want to be able to replicate your application to another location and run off of that other location at the same time. Typically in the industry, we see disaster recovery as being defined maybe in the hundreds of miles in terms of separation between the various locations, which effectively introduces different patterns for how you build your application because of the latency. So if the latency is in the hundreds of milliseconds, you're unlikely going to make your user wait, a few hundreds of milliseconds of round trip on every interaction with your app. But that's also one mechanism that's also very well used in terms of protecting against failures. And then the third, which is kind of a combo between the two, is really what we call backup. So you could imagine that you might be running an HA workload in one region, backing up some portions of its data to a distant region or to a set of distant regions. And then in the case of a massive disaster in the first region, you're able to hydrate a new deployment of your application in that secondary region somewhere. Now, how do we help you achieve that in terms of actual mechanisms on Azure? So if we look at virtual machines as one of the key base components that are used, we talk about things like availability sets. And availability sets are effectively a mechanism that protects you against hardware failures in the scope of a region or a data center. And as we all know, hardware fails from time to time, so you want to make sure that you're protected. But the second piece of protection that it gives you is also against software updates. So as you're deploying your app or different versions of your app, you want to make sure that you're not taking down all of the various resources that the app is running on in case there's a bug. The second layer of protection that we provide is what we call availability zone. And that kind of expands the scope of your protection. It gives you protection against data center level failures. So imagine a whole bunch of hardware going down for some reason. And it protects your application against that level of failure as well as software at the availability zone level. In general, we design regions with 3 availability zones. So you'll see more of that in the conversation. The reason for that is because applications that store data and that want to automatically recover typically have to have some quorum-based mechanism to recover. You cannot achieve quorum with anything less than 3 redundant units that are available to you. So those 3 availability zones give you the ability to run quorum workloads on Azure with high availability. The third mechanism is region pairs. And region pairs is where that disaster recovery comes into play. So with Azure, you can leverage the various regions that we have, which is upwards of 50 as of now, to pair them together and make sure that if one region where you're hosting your primary of the app goes down, you can leverage a different region as your secondary, most of the time on the same soil. So meaning you're not even leaving the boundary of, let's say, the country in which you're operating. This is super important for highly regulated workloads, like healthcare, financials, because those workloads have requirements on keeping the data resident inside the boundary of a specific country. So that's why we always design with that in mind, and we try to build region pairs on the same soil when the size of the country or the region allows for it. Okay, so double-clicking a little bit on availability zones. How do we build availability? And what are some of the promises that we make? So first of all, with availability zones, you're protected against the full data center loss, as I said. And the second thing that you can rely on is a 4.9 SLA for virtual machines that are running across availability zones. So that gives you a very high level of SLA. Actually, it's the leading SLA in the industry today in terms of virtual machines running on cloud. You take that and you combine it with the region pair, and now you have a strong mechanism of resiliency plus data residency at the same time as we talked about. So you can build highly available applications that are resilient to large disasters as well, while their data does not leave the country. So today we have 5 regions where you can use availability zones. And that list of regions is going to keep growing over time. We've basically made sure that there's coverage across the globe today. So you can see US, Europe, and Asia Pacific regions. And we're going to keep adding more regions fairly soon. We always get a question at the end, which is, when is region X going to come online? There's a lot of regions that are basically getting worked on right now to deliver 3 availability zones in the near future. So just stay tuned to that. The second question that we often get is, so how does Azure build availability zones? Are those just like carvings of the same data centers? Do they share any power or network infrastructure? And the answer is no. Every availability zone consists of independent data centers that do not share power, network, or cooling across the different availability zone. Because the promise that we're trying to make here is we want to make sure that if one availability zone fails, the other 2 in the region are not impacted by the same failure. So that's our design point. Also, most often, these availability zones are actually separated by tens of kilometers. So as you can see, this is a real example of our France region. In fact, our France geo, which is not shown here, but if you abstract a little bit even to the France country, we have 2 regions. One, the France central region that's shown here on the map, that's Paris. We have a second region in France south, which is in Marseille. In France central, you can see that there are 3 availability zones, and those are literally tens of kilometers apart. We even placed them strategically across different locations in France, across the Seine River, to make sure that any flooding or whatnot of the Seine River, which has happened like a couple years ago, keeps at least 2 of the AZs safe if that were to happen again, right? I know that all of these sound like fictitious or events that might not happen in our lifetime, but even if we look just at the recent past, earthquakes, volcanoes, just in the recent couple of weeks ago, less than a year ago, flooding, all of these various events happen, and when they happen, we want to make sure that they don't take down applications, especially when applications are potentially running life-saving mechanisms that, let's say, the police is relying on to actually find people impacted by certain disasters, right? So we want to make sure that all of these various things are actually protected at the highest level of availability. Now, as you start building applications using availability zones, there's two models to think about in terms of services. There's what we call zonal services. So think about virtual machines or disks. And those are services where you're going to have to create multiples of these resources and put them in various availability zones to leverage the protection that you get from availability zones. So really, that's user configured, right? Zone redundant services, on the other hand, is where Azure, as the platform, automatically replicates data and gives you a promise in terms of making sure that your data is safe in case of a zone loss. So examples of that would be Azure Storage or Azure SQL. Or recently, we actually announced a preview of what we call a zone redundant application gateway, so the networking stack, where you create one of those resources. So you create one Azure SQL database. It creates its replicas across the 3 availability zones. And if there was ever a zone failure, Azure SQL as a service fails over to one of your replicas and promotes it to become your primary for the application. Your connection string doesn't change. You don't have to actually wake up to handle any of those events. They're automatically taken care of behind the scene for you. So with that, this is basically the set of SLAs that you get, which is really the most comprehensive portfolio in the industry. You get a single VM SLA, which speaks to the fact that even within a single data center, a single virtual machine is highly available, and we're willing to back it up with a financial guarantee. The second piece of it is availability sets, which is protecting you against hardware failures. It gives you 3.5 nines of SLA. And availability zones give you the 4 nines. So this is basically the full spectrum of resiliency and SLAs that Azure offers. And with that, I'd like us to jump into a demo that Raj is going to show you in terms of simulating a power outage.
Thank you, Seth. Thank you, Seth. So the demo that I'm going to show, there are going to be 2 parts to this particular demo. So we are talking about northwindtraders.com, who are an e-commerce platform running on Azure Availability Zones. As you can see, this application is currently running live on Azure Availability Zones, and it is pulling data dynamically across 3 different zones, as you can see, the bottom right-hand corner where the application is getting currently served from. So I'm going to start off the experience. So just a quick architectural overview on how this application itself is built. Saad's talked about zone redundant services. For this demo, we have taken advantage of 2 of those zone redundant services. For the compute layer, on the top, as you can see, we have zone redundant virtual machine scale sets. And we have configured the instances within the scale set to be distributed across 3 different zones in the central US region where availability zones is currently available. Okay? All these instances of the virtual machines are connected through the load balancer standard SKU, which is another zone redundant service that Saad talked about, which protects even the networking resource, which is the IP address and the load balancer associated with it, is replicated across the 3 zones so that there is no single point of failure from a networking layer perspective. Then you have the compute layer. And from a storage point of view, we have taken advantage of zone redundant SQL database, which is also running in the central US region. So this basically is a simple, you could think of a 2-tier web application that is running on Azure Availability Zones. So as I mentioned, there are two scenarios that I'm going to talk about today. I'm going to start out with a scenario, as Saad mentioned, which is the power outage, which is the infra operations scenario, right? Cyber Monday happens to be the most busiest and popular day for northwindtraders.com. And the question for them is, when the application is running and the customers are using their service, can it withstand a critical environment failure that is about to happen? So as you can see, the application is running fine, and there is power fluctuation going on, and zone 3 went down on this particular instance. So as you could see, zone 3 has stopped working. However, from a customer application, so we have the operations person looking at it, and he's new to the infrastructure management, and he's panicking in terms of zone 3 being gone down, and it's going to have an impact on their business continuity. And he reaches out to his manager to understand what really happened, and she explains that this application is actually running on availability zones, which ensures that there is redundancy and replication across 3 different zones. And the power outage event that actually happened at this point of time has taken down only one of the zones. And as you can see here in the bottom, this application is now getting served from zones 1 and 2, but not from 3, because zone 3 is down because of the power outage. So if you think about the value proposition from a availability zone's point of view, is that it is protecting from the data center level failure. I will come and talk about the software failure scenario that can happen, and how you can protect your applications by taking advantage of availability zones. So the net impact is that there is no customer impact, right? So this is a basic demonstration of how availability zones is able to protect the application in case of a power outage, which could be because of utility service provider going down, or could be because of a natural disaster, right? This is a fictitious scenario. Now I'm going to call Dave onto stage to talk about the real-world implementation of Adobe's application on availability zones and how they are protecting their application from disaster events like a power outage. Dave, over to you.
Thank you, Saad. Thank you, Raj. Adobe's been working quite a bit with both Saad and Raj and their team for about a year now, I think, somewhere around that. And we've been actually running production workloads on Azure availability zones for our customers since last fall. So during preview periods, by working closely together with them. So one of those solutions that I want to talk about, and we're going to walk through this example of actually how we've designed Adobe Experience Manager, which is Adobe's web content management and digital asset management solution or service that we provide for our customers. I'm going to talk through how we design that and actually how the resiliency of that application works, as well as how we have gone about testing that resiliency to validate that that actually works. There's some pretty cool things in that area as well. So let's step into it. Actually, the first thing I want to call out is there are 3 primary components for Adobe Experience Manager. I'm going to call it AEM for short, so I don't have to repeat that long name over and over again. So AEM has an authoring part. That's where the customers produce their content and edit and upload that content. And then it also is responsible for distributing that content across the publishers. The publisher's job is to take that content and serve it up, okay? And they serve it up to the dispatchers. And the dispatchers are basically a caching layer. They're a content caching layer built mostly on Apache, okay? So fairly simple components. They do horizontally scale, but they also come in a set of predefined availability offerings. Now, these are the Adobe availability offerings. As Saad and Raj mentioned, underneath, for example, VMs spread across availability zones, there's 4 nines financially backed SLA. This is the SLA we're providing to our customers depending upon the configuration of Adobe Experience Manager on top of Azure. So here's 3 examples. 99.5, which is really just one dispatcher, one author, one publisher in one AZ in one region. And for some customers, that works just great. That's all they need, and that serves them just fine. For other customers, little bit more availability guarantees. Then we take that and we distribute that across 2 availability zones in the same region. So then we duplicate the dispatchers and the publishers across those. The author, that's on the content creation side, and on that side, that's not what our Adobe's customers are worried about from an availability standpoint. So the author is just on an active standby scenario, where the publishers and dispatchers, those are active, and load is distributed across those. Now, if we want to step that up a notch for some of the larger enterprise customers that can't afford even a $99.9 SLA, they need something better than that, then we step up to $99.95. And then what we do is we take that single region configuration with 2 AZs and we duplicate that. So now we have 2 regions with 2 AZs in each region, and dispatchers and publishers spread across those 2. And then we have the author in an active, passive, or standby scenario between in AZ1 of region 1 and AZ1 of region 2. Okay? Now let's step in and look at how does this actually work from a flow standpoint, as well as how does the resiliency actually work. So this is the example of our current configuration that we have running in production for our customers for $99.9. Okay? So in this case, we've got health checks from the zoned application gateway. Now, this is a preview gateway that we're using with a special arrangement from Microsoft that allows us to be an early adopter customer, help them, and they're helping us. This is moving over to the next version of the application gateway, which is the zone redundant, which is in preview and we're testing. I'm going to show you that architecture too. But the key thing here is the zoned application gateway is doing the health check to the dispatcher. So the traffic manager then is doing the health check to the zoned application gateways. Now, if that's where the health checks are taking place, what does the actual flow look like for the user? Well, the first thing they do is their client will do a DNS resolution traffic manager, which is an intelligent DNS, which has health checks, as we showed, built into it. And it will respond back to the customer with a DNS resolution that will distribute the load across the different zoned application gateways across 2 regions. Again, an active scenario. Okay, so now what happens if we have a availability zone failure? Okay, so let's say we lose availability zone 1, traffic manager does a health check to zoned application gateway. That is showing unavailable, so it will mark that down. And so when the users make requests to traffic manager, it redirects all traffic to the zoned application gateway in availability zone 2. I'll talk a little bit about the results of our failure testing here in a minute with that design. Okay, this is the architecture based upon, and this is our go-forward architecture based upon what's in preview today, and we're doing testing with this today. In this case, we don't need the traffic manager to distribute across availability zones because the zone redundant application gateway does that for us. So the customer just makes a direct, first of all, showing the health check, and now showing the customer flow. They're just making a direct SSL connection to the zone redundant application gateway, to doing the SSL termination, and then it's distributing the traffic on to the dispatchers and onto the publishers. Okay, so let's look at this from a failure scenario. In this case, the zone redundant gateway is doing the health check, finds that it's down, so all future requests then from that gateway go to the dispatcher on availability zone 2. Fairly basic, right? But the key thing is it works. Now, let's step the game up. Now let's go up to 99.5, where we've got a distribution across 2 availability zones. Now when I get into, 2 regions. Now when I get into that scenario, now the traffic manager needs to come back into the configuration because it's handling the traffic distribution across regions, and the application gateway, the zone redundant application gateway, is handling the traffic distribution and health checks but across AZs in the same region. Okay, so what does that flow look like? Traffic manager requests distribute the traffic to the different zone redundant gateways in the different regions, and they forward the traffic on. Okay, so let's look at a couple of failure scenarios and how they work in the 99.5 scenario. First of all, if we had just a single AZ failure, just like before, the health check from that zone redundant gateway picks it up, and all future traffic will then get redirected just to availability zone 2 and the other availability zones in the other regions. So region 1 just uses 1 AZ, region 2 still is handling traffic in both AZs. Okay, so what if now I lose the region, okay? The health check from Traffic Manager is doing the health check against the Zone Redundant Application Gateway. That fails, so then all DNS responses back to the customers, our clients, are actually then directing all or resolving those DNS requests to IP addresses that are pointing at Zone Redundant Application Gateway 2 in Availability Zone 2, okay? Pretty straightforward, but again, it works. Now the big challenge, these are one of the challenges that in my kind of career as a solution architect at AWS and at Microsoft and now at Adobe, I always wanted to be able to do failure tests where actually we're dropping the whole environment, right? So how do you do that? That's not an easy thing to do. Well, within Microsoft, they do, for example, when they have a new region come online, for example, Todd was showing the France-Paris region. So they had 2 regions come online in January, February. I think the tests were in, the down drills were in January. Now, in that scenario, preview customers were invited to join in and take part in the down drill. So we had our application installed and configured, and the way the process works is they actually power down an AZ, power the whole thing down, and then we get to see what the result was on our application, our solution, and all the interactions with the Azure applications and services and how they're behaving in a scenario where they just powered down a full AZ. And then they went through and powered down another AZ, and then finally a third AZ, and failed over to another region. So we were able to see how that worked and behaved, and I'll show you a little bit of those results. There's also a it's a production representative set of regions that Microsoft uses, because I always wonder, so how does Microsoft validate in Azure land? How do they validate that all their services will work just fine when a bad event happens where you lose an entire AZ or entire region? They're validating their services are working like that, working just fine in a down drill as well. And for us, that brought a lot of confidence, right, in seeing that they're able to actually go through and perform those tests and validate everything under the covers that we're depending upon also is functioning in a very resilient manner. Okay, so took part in the France zone and region down drill. So what did we learn? First of all, we learned that the TTLs, the time to lives that we were using for Application Manager, they were default at 5 minutes. Now there's some trade-offs on TTLs. If you get them too low, then you've got a lot of requests going to DNS. And so you have to pick a balance that works best for you. In our case, we brought it down to 1.5 minutes. And in our experience, down to 1 minute. And what we found was that in the first drill, it took about 5 minutes for our application to get back to a stable state while DNS resolution and Traffic Manager were kind of working through that time to lives window. We chose to drop that down to 1 minute, and we're now at 1.5 minutes. So the next down drill we joined, then the experience was 1.5 minutes, and that's within the targets that we wanted to achieve at Adobe. The other thing that we noticed was when bad things happen, they don't always happen in the order that you might expect, either down or coming back. And we hadn't really thought through very well how our services recover when things start to come back up in a zone. So in this case, what we found was that our health checks on Traffic Manager and on the application gateways, they were fairly simplistic. Are you there? Yes, I'm there. And what we needed was health checks that actually would go and check much deeper, because the application gateway came up before our actual dispatchers and publishers came up. And we accounted for that in our health checks. Sorry, my mic's cutting out a little bit there. So that was one of the lessons learned, and these are really helpful, valuable lessons for us to learn as part of that down drill process. Then we took part in the next down drill and validated that everything came back up in the way that we expected with the deeper health checks. Okay. Lessons learned. I kind of covered some of these already, but the first one is probably the most important. Where availability zones are still being deployed throughout Azure, first thing, do your homework. Go in and take a look, see which regions have availability zone support, and see if that maps to the regions that you need from Azure. Also, go and look at the services that your solution is consuming and validate that those services are supporting the availability zone. So that's the first thing. Do your homework. Just validate that what's available aligns with what you need. And if not, then check with Microsoft on plans, okay? Second is automate your environments. Automate the provisioning of those, especially the dev, test, and or dev stage and production. If you have automated your environment, it's very easy for you to then jump in and take part, say, in a down drill. Spin that environment up and destroy it. We noticed that teams who didn't automate, they looked at it and went, oh, man, that's a lot of work. But teams that had automated their environments, piece of cake. They jumped right in, learned what they wanted to learn. So next thing is automate. The next one is automate the recovery processes. If it's manual, if you think you're going to go to the CLI or go to the portal and bring things back up, that blows out your SLAs. It just takes far too long for you to do that. Make sure that you've built into your design so that it automatically recovers from down events. That's really key. And then the last one we mentioned, which was a big aha moment for us, was also validate the recovery when services start to come back up, because our first pass through it, we were actually impacting our customers as things were coming up different than we expected. So validate how that works for you as well. So that's it. Thank you very much. Back to Raj.
Thank you, Dave. I'm going to switch back over to our demo here to talk about the second scenario. So basically, we are resetting the entire demo environment so that we can go through the second workflow that I had showed you as part of the initial experience. So it's going to take a couple of minutes here. Yep, we are back up. So it's the same northwindtraders.com e-commerce application. Just a refresher on the architecture itself. This time, I would like to draw your attention to the application version number that you're seeing on the compute instance and the database instance, which is also getting popped up here, right? So it's 2.1.4 is the current version. So the scenario that we are going to see at this point of time is happening is, how do you protect your application from software update related failures, and to make sure that that's not going to take down your entire application. So for this experience, I'm going to choose the DevOps workflow. So again, the setting is the same. It's on a Cyber Monday. The question is whether, from a Northwind Traders point of view, can they continue to execute their CI/CD pipeline even on a day when they are going to be very busy in terms of their application traffic. So that's the challenge that they are faced with at this point of time, right? So what I'm going to do at this point of time is going to switch over to the PowerShell console and push a code version which contains bad bits. So I'm going to just zoom it up a little bit. OK, can you see that? So basically, this is a PowerShell which is going to push out the new version of the bits, which is 3.0.0. As you can remember, the current version that is running on is 2.1.4, and I'm going to push this code out to zone 1 of where the application is running. So I'm going to enter my password. So this is currently deploying to zone 1. The deployment was successful, but unfortunately, it has taken down the application. So as you can see, the app version 3.0.0 is running on zone 1. The previous version, which is the healthier version, that is running on 2.1.4, right? So if you think about your rollout process, you can adopt the capabilities of the availability zones construct to be able to structure it in such a fashion so that it is rolled out in a paused fashion. So let's say you roll it out into zone 1, have some amount of bake time, during which you can go ahead and test your application, whether the bits that have been pushed out has been successfully deployed or not. So in this case, as you can see, this has taken down the application in zone 1. And we have the developer who is looking at it and being concerned from the apps manager in terms of the application has gone down. She's going to reach out to the developer, and the developer looks at it and says that, yeah, I recognize that there is a problem in the software that we have just rolled out. Good that we have a pause mechanism. Therefore, it has not taken down the entire application. Customers are not facing any downtime, which is a great thing, right? They are going to work on a fix right now, and then they are going to push out the good bits, right? So now I'm going to switch back over. Now, they've made the changes to the code, which fixes the bug that had taken down the application in zone 1, and they've versioned it as 4.0.0, and they are now going to push it out to zone 1. So deployment is currently in progress, and it is going to take a bit of time in terms of making sure that the code changes are being successful. And we will be able to view when the application comes back up on zone 1 here in a minute. So the idea beside protecting your application from data center level, infrastructure level failures, be it utility going out or natural disaster taking down, you can take advantage of availability zones to introduce a safe rollout mechanism in your software deployment as well, so that you are protected from any software-related failures. So as you can see, the deployment was successful, and the application version is now 4.0.0, and soon this will make sure that the application on zone 1 is also ready and up and running. So as you can see, now zone 1 is back in healthy state, and you can do the testing at this point of time to make sure that the version that is running on zone 1 is of good quality, and it is safe for you to roll out to the other 2 zones as well, right? So at this point of time, what we will be doing is we'll be pushing out this version to all the 3 zones. And going back and looking at the infrastructure view, you will start seeing the version numbers in zone 2 and zone 3 also moving to 4.0.0, which is the healthy version after the fix has been put in place. So as you can see, zone 2 app version has been updated to 4.0.0. Same is the case with the database. And then we'll see zone 3 as well. And you can see it is getting pulled live. Zone 3 is still running on 2.1.4. Whereas zone 2 is 4.0.0, and zone 3 is updated to 4.0.0 now. So at this point of time, you made sure that you've not taken down your application completely. Though there was a bug in the version that you had initially rolled out, you had the capability to stop the rollout, fix the bug, and then push it out and make sure that everything is fine. And northwindtraders.com were not impacted because of the software bug that was introduced. So summarizing again, protection from data center level failures, software failures, and natural disasters that may impact the data centers on which Azure is running on. So that was another successful rollout for northwindtraders.com. Thank you.
Thank you, Raj, and thank you, Dave. So, as I promised earlier in the conversation, I said, we're going to talk about how you build applications on Azure and keep them running without involvement necessarily, from you as things go wrong. And I think we've demonstrated that through Raj's demos and through Dave's, actual practice in real life, that that's actually true and feasible. So just a few things, to kind of think about before we get into a little bit more of the actual experience of using availability zones is, one, the next time that you hear that Azure is launching a preview of a region, reach out to us, participate if you want to try out, deploying an application and participating in some of these drills. It's one of the unique differentiators that we have in the industry, and I think it helps you build more resilient applications in the long run. We definitely benefit from it, as Dave pointed out, even for Azure services. The second thing that's also worth noting is make sure that when you're running these drills that, yes, you have people lined up to help you fix issues and whatnot, but also don't expect them to be very involved. If you've done your job right, which is what Adobe found out, they had lined up multiple operations folks in a location, and everybody was on call trying to figure out if something is going to go wrong. It was pretty much a non-event because the app was architected as we've just showed you. So just keep those things in mind as you're developing. And now let's actually talk a little bit more about specifically how do you leverage availability zones from an experience perspective. So first of all, how many of you use the Azure Resource Model, or ARM? Show of hands. OK, that's pretty good. So availability zones are exposed through ARM. That's the most important thing probably through this conversation. And this is also what makes it fairly easy to move or adopt availability zones if you have applications running on Azure already. Now, we've also created certain constraints in the resource model specifically for availability zones to add this extra layer of protection. So when you're creating a virtual machine, as an example, the disk that's backing it up and the IP addresses that are also backing it up need to be in the same zone. Because we don't want a disk going down in zone 2, taking down your VM, which is running in zone 1. So we tried to enforce a lot of these constraints so that it helps in terms of additional protection for the application in case someone by mistake deploys something across zones. The other thing that's important to mention here is when you look at IPs and load balancers from an AZ perspective, there's a new IP and load balancer that we've introduced a few months ago called standard IPs and standard load balancers. Those are actually super important because they run with Anycast in the background, meaning that you can use one IP address that's Anycasted to 3 availability zones, and it'll automatically detect if one zone is down and route traffic to the other 2. The reason why that's beneficial is if you're building, let's say, an IoT application where you're programming devices to use an IP address, or if you're building a web application where your DNS might have, as Dave pointed out, a certain TTL in terms of the IPs that it's fronting, then you're always going to have downtime if you had multiples of those. Because until the DNS realizes that one of its IPs is no longer healthy, you're still routing traffic to it, so your customers might be down. That's also assuming that the client is honoring that. But with a single Anycast IP, you remove that layer. As soon as Azure detects that a zone is down, the IP address routing is updated through Anycast, and you don't have to worry about any of those things. So it even reduces the timeout or the time that your application is down to even lower. And you've seen that with Raj's example. As he did the deployment, once the application picked it up, within seconds, the load balancer realized that something was wrong or something was up again and routed traffic to it. One other thing worth mentioning as well is subnets span availability zones. So you don't have to create one subnet per availability zone, which might be a model that you're familiar with elsewhere. This makes it a lot easier in terms of management and in terms of building applications that are resilient. Now, we also tried at a very high level to make the model very generic and very easy to adopt by simply introducing one extra property to your ARM templates. So if you built ARM templates today that deploy a very complex application on Azure, this shows you how you change it. So for virtual machines, manage disks, add a zone. For load balancers and IPs, just simply add the SKU type, which is standard. And your application now, once you deploy it, is zone enabled. It's as simple as that. Now, if we look at zone redundant services, as I mentioned, there's zonal, zone redundant services. So for zone redundant services like VM scale sets, which is a super powerful mechanism, especially if you're running a stateless web application, you can tell it to go across multiple AZs. And if an AZ is down and you need additional capacity in the other two AZs to handle your load, VM scale set in conjunction with Azure Autoscale will detect that you have less capacity, and they'll go on your behalf and create more capacity in the additional zones. Similarly, SQL database, Azure SQL, and Azure Storage will do something similar in terms of you talk to a single endpoint, you store your data, you write to your database, you read from your database, and if there's any failure, it picks up. And you can see how easy, again, it is to switch over to using those. So in general, it's really literally one property change on your ARM template that gets you into a zone model. OK. So with that, a few calls to action. So familiarize yourself with some of the content that's available online as well. The second thing that I'll say is, if you're here for the rest of the week, please visit us at the booth. We have a booth for availability zones where we have an IoT demo, and then we have a few of the demos that Raj showed here in more detail, where we can go and talk about some of these implementations and figure out how we can help you architect your application on availability zone if you're thinking about it. And with that, we're going to switch to Q&A. We have a microphone here in the center. And given that all of this is recorded and captioned, I would appreciate if you could use the microphone to ask questions. And Raj and Dave, if you want to come up here as well.
So you showed a deployment that was just using a coded deployment to a single VM. Is there any pattern for doing that with ARM deployment? So being able to roll out a deployment to like a scale set via an ARM deployment that would go availability zone by availability zone? Or is that not available yet?
You want to take that, Raj?
It's not available out of the platform, out of the box, right? So you would want to have the template roll out in such a fashion, as you saw the zones parameter, you may want to control it to zone 1 or zone 2 or zone 3. And once you validate, then you can roll it out to all of the zones. So if you say that in the ARM, if you choose all the 3 zones where the application is deployed, and you use the same ARM template and roll it out, it's not going to protect, right? It's going to be controlled by you.
Yeah, and let me add a few more things to that. So through ARM is really helping you in terms of provisioning the infrastructure and configuring the infrastructure. But once you get into the application layer, you want to leverage a deployment mechanism to help you with that. So if you're using something like Jenkins, or if you have your own custom deployment pipeline, what you'd want to do is you'd want to group the set of VMs that are in one zone and deploy to them first, and then group the second ones, deploy to them next, et cetera. We are actually building internally an Azure service that gives you part of that functionality, so you should see that fairly soon. The other thing that you can do as well is there's information inside the VM available to your application that tells you in which AZ it is. So one pattern that we've also seen folks implement is the application, you might go roll out the new application bits to all of your VMs at the same time and have them be dormant. And then you could wake them up through detection of which zone they're in and slowly, basically flip the bits out, either through a rollout, through like, let's say, an Azure blob, You can say, enable this in zone 1, and the application checks if it's in zone 1, it'll turn up. So we've seen those various patterns, but in general, ARM is really like deploy your infrastructure and configure it, and then deployment to your application, use continuous integration or some deployment pipeline to leverage that.
Obviously, we use image-based deployment, so it's sort of...
It's a combo. Yeah, okay.
How does Service Fabric work in availability zones?
So for Service Fabric, we have actually some guidance on how you can configure Service Fabric in availability zones. We're happy to share more details about that at the booth if you can stop by maybe tomorrow. But at a high level, you effectively want to create the ring across the 3 availability zones using 3 independent virtual machine scale sets, 1 per zone, and connect those through a traffic manager fronting all of them.
So, I mean, is it 1 giant managed cluster in that case, or 3 separate Service Fabric clusters?
1 giant cluster.
Okay.
Yeah. And in fact, that's how we use it internally, even for our services.
Hi.
Hi.
How mandatory is the demand for free availability zones versus today when we use availability sets and we can only use 2? And therefore, if I use free availability zones, and I will have to put more machines and more nodes, and which cost more money, is it possible to provision free zones with scalability sets that will automatically generate the new machines in the missing empty zones rather than provision the entire free zones from scratch?
Yes. So first of all, you can decide in which zones you want to deploy your virtual machines. So you could say, I want my virtual machine in 1 zone, or I want 2 virtual machines in 2 zones, right? There's no requirement that says you have to deploy across 3 zones. Typically, applications that leverage the 3 zones are ones that require quorum. So as an example, when Dave showed the Adobe Experience Manager service, it was designed mostly to run in 2 availability zones, not 3. If you want also the automation to be able to scale to 3 or to scale more even within the 2, then with VM scale sets, what you do is you create a zone redundant VM scale set, and then you can tell it that at a minimum it needs to create VMs in 2 zones. And you either go and add an extra zone when you want to scale to 3 zones, or you can configure auto scale, which is another Azure service, to work in conjunction with your VM scale set and add additional VMs based on some metric or based on some event that triggers additional capacity to be added. And those could be spread across 3 zones or 2 zones.
Thank you.
Yeah.
Hi, you mentioned the SQLDB and storage account are supported by availability zone. What other PaaS services are supported? For example, analysis service, data factory, and one we use and it seems to have a gap is the Azure Key Vault.
So right now, the 3 key ones that are supported are Azure SQL, Azure Storage, and then gateways. So Data Factory, Azure Key Vault, and other services will be coming online soon. And I'd like to also hear maybe a little bit more about your use case after this talk in terms of where you need Azure Key Vault, for example, to be replicated across 3 AZs.
Hi.
Hi.
We're using app service and thinking about putting in traffic manager. The Anycast IP addressing, is that relevant to Azure, relevant to platform services, and do we still get the geo IP mode where it picks the closest? If we use Anycast, do we get the geo location lookup for the DNS?
Yeah, that's a good question. So with Traffic Manager and IP management, think of Traffic Manager as what you want to continue using when you're looking at location-based routing from a DNS perspective. So if you want to route to a specific app service closer to you, then yes, you want to continue using traffic management. If within a region, within a specific region, you can use the Anycast IPs and load balancers. to route traffic to a highly resilient application, be it an app service or something else, right? So you kind of want to use those two mechanisms in conjunction as one versus the other.
So Anycast is not really relevant in the...
No, it's not Anycast is really within the construct of a specific region, and what you need is that plus traffic management to route to multiple instances of the app service. Yeah.
And I'm back again.
Hello again.
So my second question was, I assume the guidance is to use availability zones instead of availability sets wherever availability zones are supported. The only difference I can think of with that, though, is there any sort of performance hit you might take from having communications between maybe a cluster that isn't stateless, might have to share some state between the servers, by the fact that they're now in separate data centers further apart than just in different in the same availability set in a single data center?
Yeah. So you definitely nailed it right there, which is the trade-off that you're looking at between availability zones and availability sets is one of performance and latency. So with an availability set, your deployment is going to be co-located within a data center, meaning that you're likely going to experience a faster connectivity between your virtual machines, whereas for availability zones, your VMs are going to be located across data centers, which likely is going to increase your latency. So the answer really depends on how latency sensitive your application is versus how resilient you want it to be. In general, what we've seen is many applications can tolerate the availability zones latencies, which are lower than 2 milliseconds round trip between VMs. And that's why we recommend it for things that are doing synchronous replication in nature.
Okay, thanks.
You're welcome.
I kind of have the same question. For SAP workloads, we see that we have an issue there with the latency between the zones. And can perhaps accelerated networking help there?
Accelerated networking definitely helps there. Let me ask you this, what is your expected performance or latency between VMs for SAP?
I think it should be less than 1 millisecond.
Okay. So I think with that, the way that I'd recommend to architect is you probably want to look at potentially an active-passive type of architecture with SAP, where you're running your primary in one availability zone, and if that fails, you fail over to a second availability zone and asynchronously be replicating the SAP workload.
Yeah, but let's say you only have one app server, one database server, then we don't have all types of hardware in all zones. So if you deploy that, you need to be aware of the availability zones to have them in the same building.
Yes, and so the way that you deploy it is you'd say, I want my primary in availability zone 1, and you'd have to say you want your secondary in availability zone 2. Granted, by the way, you don't have to even run an you don't have to run a workload in the secondary zone for you. You could just back up your data if you're okay, taking more time to bring it up when there's an outage, right? So you can back up your data and you can back up your VMs as well. And then when there's anything that goes wrong with, let's say, your primary zone, you can go to a secondary zone and spin up exactly the same database and the same VM and have them be co-located. My point to you is that if you're looking at sub-millisecond latencies, those are typically located closer than two availability zones. So that means you have to run them inside the same availability zone.
Yeah, so if you go for the 99.9 SLA, you really need to look at the availability zones when you deploy the server, because not all hardware types are available in the same zone.
Correct. And so for your workload, I recommend actually availability sets as opposed to availability zones. Yeah.
Okay, thank you.
When we talked about a free tier model, okay, if the traffic manager sends the packet to one of the web servers in, let's say, zone 1, will the rest of the transaction be performed in zone 1, or is there a chance that it would leak into other zones also and increase the latency for the general transaction?
Okay. And when you say transaction, you're talking about an Azure SQL database? Or what is the backend that you're transacting with?
Let's say Cassandra or anything else.
Okay. So for something like Cassandra, what you'd probably want to do is you'd probably want to write to to the VM or the set of VMs that are in the same zone as your application server that's handling that transaction. And as I said, so on each VM, there's a service that exposes metadata within the VM, and it tells you exactly what zone it's in. And so that's advertised to Cassandra, and it's advertised to your application. And all you need to do is say, if the application has received a request, let's say in zone 1, route it to a VM that's running Cassandra in zone 1. So that's the pattern that you want to follow. And then Cassandra itself knows of all of your VMs within the Cassandra cluster, and then it can replicate the data across.
Okay. It's not isolated by itself.
It's not.
Since it's share the same subnet.
You can actually define one subnet per zone, but that's not going to help you with what you're talking about. Because even if you had different subnets, you still want to make sure that the application, in terms of one VM in zone 1, talking to Cassandra VM in zone, is also talking to a Cassandra VM in zone 1, not in a Cassandra VM in zone 2.
Okay, thank you.
Two questions, if I may. Historically speaking, how many times did you experience the whole region being down, if you have that kind of data?
Sorry, say that again.
How many times did you experience the whole region being down?
I don't know that I have this kind of data. Region down events are actually very infrequent. That's what I can tell you. And we don't see them very often. But when they do, they cause a lot of customers a lot of pain, right? And this is why we try to actually think about protection against them ahead of time. Yeah.
Second question. Let's say that I have that configuration with, let's say, 2 availability zones, right? And now one availability zone is down because of some infrastructure issue, right? Can Azure automatically spawn my services in one of the availability zones that is still up in the same region or in a different region? Can have that kind of configuration?
So the answer to that is yes, within the same region. And the way that you do that is by using something like VM scale set, as I mentioned, plus auto scale. So autoscale is basically an additional service that works with VM scale set, and it reacts based off of health metrics. So basically, if it detects that one zone is down because let's say 5 VMs went down at the same time, what it'll try to do is it'll try to go and launch another 5 VMs in another availability zone for you and route traffic to them instead. So that's how you basically build that pattern in terms of shifting from one AZ to another if there's an outage.
Thanks.
You're welcome.
I'm planning to run app service in 2 different AZs and to be pointing at one SQL connection string. Is it okay to allow users to be active on both web tiers, but to be connecting across from this sort of secondary web tier to the database and the primary data, all going to the same database across availability zones? If my application can stand the latency of those, is that a sound design?
I would actually recommend you doing that. So the reason why the way that we designed Azure SQL for zone redundancy is a single connection string as opposed to 3 is because we wanted you to do that. Because ultimately, if you have to think about switching connection strings when stuff is down, you get back to the problem of no auto recovery, right? So like Dave's principle was auto recover as much as you can. And for you to do that, we don't want you to be going and changing the application in real time. Yeah.
Thank you for that.
Especially during an outage. Yeah.
Hey, so I'm using a standard load balancer with a scale set right now. Mm-hmm. And I was wondering, I want to upgrade it to a cross AZ scale set using an ARM template. So how would that look? Can I actually upgrade an existing VMSS? And then a follow-up, what would happen to the existing VMs inside the scale set?
Okay. So migrating from an existing deployment of a VM scale set to an AZ-enabled one is not something that's supported today. So effectively, there's a bit of a orchestration that you have to do that. So the way that I recommend that you do that is create a second VM scale set that is zone redundant, set it up, make sure that it's working, and then switch the load balancer that's pointing to your first VM scale set to point to the second one that's distributed across zones, and that should just work.
Right, thanks.
Wouldn't that load balancer then have to be a standard load balancer, though?
Yes, he said he's already using a
he's already
standard
got
one.
a
Yeah. Yeah.
So one other question then. So you had mentioned the outage scenario where servers, the skill set automatically creates servers in the working availability zones. Would it, after the original availability zone recovers, would it then realign back? Do you know?
Would it rebalance? So it's not going to attempt to rebalance automatically, or at least not immediately, because we don't want to cause a storm of things moving at the same time, which might also cause another outage. But the way that you can basically address that is once the zone is healthy and you've made sure that it's healthy, for your application, you can just go and, let's say, shut down a VM in the other application, in the other availability zone, and then VM scale set will actually bring it up in the right zone. So we're giving you control over that so that we make sure that we're not causing a storm of migrations into that availability zone that just came up and potentially cause another outage for you and for us.
Got it. Thanks.
Okay. Thank you, guys.